Welcome back. Let's see how we can implement the insert method. And this was a tough one, so hopefully you got it. If not, at least you tried so that we can see how we want to implement the insert method properly. The very first thing I want to do is, well, first of all, check my parameters. And this is something that you usually want to do with all methods. I know we simplified things, and when we looked at prepend and append, we never checked whether the value was something that we wanted. But when it comes to inserting something, we want to make sure, especially that the index is a value that we understand, so our program doesn't give any errors. And there's many things that we can do for a check, and I'll leave it up to you to really implement really good checking. But the one important check that I think we should have is if index is greater than or equal to this dot length. So if I give an insert of, let's say, index at 200 and our list is only 3 items long, I want to be able to handle that properly. In this case, I'm saying as long as the index is greater or equal to this dot length, in that case, just add it to the end of the list. So if I say insert 200, value of 99, I'm just going to add the 99 to the end of the list. And you can implement different variations of this. Maybe you can return an error if you want. But to simplify things, I think this is good enough. And we can just say return this dot append, which we already have. We have to say this dot append because we're referencing a method in this class. So let's say this dot append. And we'll just add the value. There we go. So if I do 299 over here, let's add the print list at the bottom here. And if I click run, I get 99 added to the end of the list. But what if index was 2? Well, this now is the hard part. We want to first create the new node. And remember, we can create a new class instance if we wanted to, but in our case, we'll just create a new object that has a value of value and next of null. Nothing new here, we've seen this before. Here comes the tricky part. And I like to comment this out or at least visualize it so we understand what we're doing. We have 2 nodes that are connected. And then we have a new node that comes along and says, hey, I want you to insert me right in between here. What should the steps be? Well, the first thing we need to do is to actually figure out which node the first one is. Because remember, to insert something, we can pick whatever index we want. So if we want to insert at index of 2, we want to grab whatever is at index of 2. So we need to traverse our list and say 0, 1, 2 to find this node and get a reference to it. Otherwise, we don't really have a reference to it. Remember, a linked list only has reference to this head and this tail. So the very first thing we want to do is to actually get to that node. And we're going to call this first node the leader, because that's going to be the first node that we're going to connect this new node to. And this new node is now going to point next to the old node, or the node that was initially connected to the first node. So I'm going to say that this leader node is going to be, well, how can we get that? We need to somehow traverse one by one until we find the index we're looking for. And to keep the code clean, I'm going to create a new method. I'm going to say this dot traverse to index is going to be a new method that's simply going to get the index that is 0, 1, 2, and I want to grab the leader. So if I want to insert the number 99 in here, I have to make sure that 10 points to 99 and 99 points to 5. So that means I need to grab the index, not here, and point it to the leader, that is the 10. the leader that we want of the list. So all I'm going to do is -1. So point to the leader, and this traverse to index, well, we're going to have to create it. And I have the this keyword here because, again, it's a method onto this class. I'm going to say traverse to index. That's going to get an index. And this is where we do our traversal or looping. We might want to check for parameters here and make sure that it's a valid index. And that's something that you can do on your own. It's not very important for this example. We can assume that the index is going to be a valid number, a valid index. And in here, we're going to first have to do something like a counter. That's going to equal to 0. And we're going to say that the current node, and this is something we did similar to the print list. We're going to keep the current node as this dot head. And while the current while the counter doesn't equal the index, because we're saying keep traversing, go from the beginning, from the head, all the way until the counter is equal to the index. So keep going through the while loop as long as the counter doesn't equal the index. But as soon as the counter becomes the index, so while we reach the point that we want, in our case, traverse to index -1, that means as soon as we get to 10, then stop. But until then, I want you to traverse through this. So current node is going to equal current node dot next. So we're going to keep moving the current node over to the right, and we're going to increment the counter 1 by 1. That's it. That's our traversal. All we need to do at the end, because we want to return something from this method, is to return the current node. And there we have it. We say traverse to the index. In our case, if we do insert to 99, it's going to receive to 99 here. It's going to create the new node, and it's going to traverse to index. 2 minus 1 is 1, so it's going to say 0 and 1. And counter is going to equal index, so it's going to exit out of this loop, and it's going to return the current node, which is 10. We grabbed a reference to the leader. Congrats. But we're not done yet, right? Once we grab the reference to the leader, what do we do next? Well, the next thing is we want to make sure that we grab the next item in this original list. That is, we want to hold a pointer to number 5. Again, we don't want to break this list. We want to make sure that the connections are working properly and that 99 comes after 10 and after 99 comes 5. So the next step we want to do in our insert method is to what I call hold, or let's just call it holding pointer. I could probably name that better, but holding pointer is nice. And we'll say leader.next. Leader.next is 5. And this 5, we now have it referenced in this variable that we'll have temporarily. Next, because we have 5 saved to this variable, referenced in this variable, we can now update the leader.next to point to our new node. So I can say leader.next is going to now point to new node. And remember, because of how references work, we've deleted the reference of 5 here. So 10 no longer points to 5, but we've saved the reference to it in here, in this variable. So right now, if we go back to our example here, we've removed the reference to this, and now 10 points to this node. That's better spacing. There you go. Okay, what do we do next? Well, we now need this node, this new node, to point to this one, like this. And that's pretty simple, right? We simply say new node dot next is going to equal the holding pointer, the 5 that we are keeping in memory. And then finally we say this dot length plus plus because we've added to the list. And we can return this, or just so we know we did it properly, I'm going to say this dot print list. Once we insert something, we're going to just print the list. Let's see if that works. I'm going to remove this so the code works and we don't need the print list. Let's run this command. Hey, look at that. So before we had this list, and let's actually print list here so we can see it. My print or my linked list dot print list. This is what we had before, and we added 99 in here, just like that. And just to test it out one more time, if I do my linked list dot insert again, and this time we'll give it 20, which doesn't exist, index of 20, and add 88, that should be added to the end of the list. And because with this insert, when we do the if check, we're just adding the this.append, which isn't printing the list. Let's just add a print list at the bottom here to make sure that that is working. There you go, 88 at the end. Very, very nice. I know that was challenging, and insert is probably the toughest function to implement or method to implement in a linked list. But practice this a couple of times, really understand what each step is doing, draw it out if you need to. But congratulations, we just implemented an insert function into our linked list. And you might notice here that we had to traverse where we had a while loop. And this might make sense now, right? Why we had the insert as O of n? Because we had to loop through our list. And lookup, which can also be called traversal, was also O of n. That was our traverse to index, right? If we're looking for an item at index of 10, for example, we'd have to look up. And the worst case is that we had to go through the entire list. Same with insert. All right, now that we've done the insert, you should be able to do the next one on your own. That is delete. Using something very similar to what we did with insert, let's add a delete, or I like to call this remove. Let's have a remove that has the parameter index of what you want to remove. Good luck coding this, and I'll see you in the solution video. Bye-bye.